Okay, so this is the second part of the review. Determine whether the two events are mutually exclusive. Okay, so now remember, mutually exclusive means that event A and event B do not overlap. So selecting a day in October and selecting Halloween. Well, Halloween is in October, so they overlap, so these are not mutually exclusive. Selecting a king from a 52 deck and selecting a diamond. Well, there is a king that's also a diamond, so the events are going to overlap, so they are not going to be mutually exclusive. 2, if events A and B are mutually exclusive, must they always be complementary? Okay, so let's think about this for a second. Complementary means that they add to equal a whole. So if I can think of one example that the events are mutually exclusive, but they don't add to a whole, then this answer would be no. Okay, so let's think here. Complementary events that are mutually exclusive. All right. Let's see. The number of pets you have in your house. Okay, so we have the number of cats and we have the number of dogs. Well, cats and dogs aren't going to overlap. Those are separate events, but they might not add to a whole because somebody might have an iguana or a snake. So there might be other types of pets. So no, they don't have to be complementary for A and B to happen. We can have things on the outsides of A and B and they still be mutually exclusive. Of events that are complementary, do they have to be mutually exclusive? Yes, because complementary events don't overlap. So yes, they would have to be mutually exclusive. Okay, so if the probability event A happens is 0.436, then what is the probability that A does not happen? So we take the whole, 1 minus the probability that it does happen, and that's going to give me the probability that it does not happen. So let's see, if I subtract, that's going to give me 0.564. A 4-question true-false test is given. If the event A is getting all 4 questions correct, write its complement in words. Okay, so all 4 questions correct. The complement of that, so it would have to add to a whole, would be getting at least 1 question wrong. So I can get 1 wrong, I can get 2 wrong, I can get 3 wrong, 4 wrong, and all of those would be the complement. Okay, number 4. Let's see, Citizens Action Committee for National Health Care consists of 6 Democrats, 1 Republican, and 3 independents, so that's 10 people total. Okay, so I'm just going to write that down as I think of it. Find the probability of getting each. All right, so here we go. A. An independent if 1 member was selected. Okay, so there's 3 independents out of 10 people total. So the probability I get an independent is 3 out of 10. A Republican or an independent. Okay, so or means add. So there's 1 Republican and 3 independents out of 10 people. So that probability would be 4 out of 10. 2 Democrats, given that 2 different people are selected. All right, so let's see. Democrats, there are 6 Democrats out of 10 people. And, because I want another Democrat, and, so multiply, a second Democrat. Well, I already had 6, so 6 minus 1 is 5 people left out of 9 total. So 6 times 5 is 30. 10 times 9 is 90. So that is 30 out of 90, 3 out of 9, 1/3. So there's a 33% chance. Oh, look how sweet you are. Now get your hands out of her mouth, okay?
She started it.
Well, you need to finish it, okay? Number 5. The two-way table at the right categorizes students by gender and grade level. If 1 student is randomly selected, find the probability of. Okay, so we're going to get 1 student, find the probability that they're a female. So they give me my two-way table over here, but it's missing the title. Okay, Gina, before you leave, can you fix Ryan's movie, please? So I need the totals here. So 35 and 45 gives me a total of, wait a minute, yeah, 80, right? Yeah, 80. 42 and 46 is 88. 38 and 34 is 72. If I add this way, Ryan, leave her alone, please. Ryan, let her face go. If I add this way, 45, 42, and 38 is 125. 35, 46, and 34 is a total of 115. 30, 40, that would be a total of 240. Angelina, can you please come fix Ryan's TV show? Okay, getting a female. Okay, so the probability I get a female, there's 115 total females out of 240 total people. Getting a male or a junior. Okay, so males is 125. I don't want to count these 42 twice, so we're going to do 125 plus the 46, right, because these are the female juniors. So if I add those together, that's going to give me 171 out of 240. Getting a junior or a senior. Okay, so juniors and seniors, none of those overlap, so we're just going to add together 88 plus 72. And let's see, 88 plus 72 is 160 out of 240 students total. Getting a female sophomore, so female and sophomore. Female sophomore is 35 out of 240 total people. Getting a female given, so I'm going to focus on the juniors. So if we're given junior, that means I'm going to ignore sophomore and senior. Oops. Can you guys see that? No, that's not going to work. That's not going to work. All right, here we go. If I want to focus on the juniors, that means I'm going to ignore the freshmen. I'm going to ignore the seniors. All I'm going to look at is the junior line. So in that junior line, the females are the 46. So this is going to be 46 out of a total of 88 juniors. All right, getting a sophomore, given that the student is male. So if I'm given male, that means all I'm going to worry about is the male category. So I'm going to erase everything else, the totals, everything except the males. And now in this category, I'm looking at sophomore. So sophomore is 45 up here. So that's 45 out of 125 males. Okay, number 7. An unprepared student makes random guesses to 8 true-false questions on a quiz. What is the probability he gets at least one answer correct? Okay, so the probability he gets at least one answer correct is the complement of getting them all correct. So this would be 1 minus, let's see, it's a 0.5 probability because it's true-false, so that's 1 out of 2 of getting it correct. And then I'm going to repeatedly multiply 0.5, how many times? Let's see, 8 times. Okay, so I'm going to do 1 minus 0.5 to the 8th power. 0.5 to the 8th power is 0.004. So this is going to equal 0.996. What is the probability that they're all right or they're all wrong? So or means that we add. So all right would be 0.5 to the 8th. And all wrong would be 0.5 to the 8th. So that's going to be 0.004 plus 0.004 is 0.008. Okay, a quiz consists of 2 true or false questions and 1 multiple choice question. Is answering all at random, what's the probability that we get all 3 correct? So this is repeated multiplication. So we're going to do this twice. So that's 1 out of 2, 1 out of 2, right? We're going to repeatedly multiply. So there's 2 questions, first question, second question. The chance I get the first question correct is 1/2. The chance I get the second question correct is 1/2. The third question is a multiple choice, so there's a 1 out of 4, because there's 4 choices, chance that I get it right. And now I multiply. 1 times 1 times 1 is 1. 2 times 2 times 4 is 4 times 4 is 16. So there's a 1 out of 16 chance I get all of them correct. Okay, number 9. A box contains 12 batteries, 9 are working and 3 are defective. If we randomly select 2 batteries, what is the probability that 1 works and 1 is defective? Okay, so there's 2 ways that can happen. Okay, so again, remember, we're going to draw a little tree diagram right here. And you don't need to draw a tree diagram on this one. I'm just doing it to explain what's happening. So I get 12 batteries out of 21. That's not right. That is not right at all. I misread that. I've got 12 batteries and 9 batteries and 3 are, okay, I got it. This is the total. 12 is the total. So we've got working and we've got defective. So working is 9 out of 12 and defective is 3 out of 12. Now I get one that works, and then I can get another one that works, or I can get one that's defective. Okay, so here I've got 8 out of 11, and defective I'd have 3 out of 11. Or I can get a working and a defective. Well, there's 9 that are still working out of 11, and then there's 2 out of 11 that are defective. Now, I want to get one that works and one that's defective. So there's 2 ways that I could get that to happen. I could get one that works and one that's defective. Okay, so if I get one that works and one that's defective, oh, I forgot I have to do this first. 9 out of 12 times 3 out of 11. Forgot this marker is kind of makes the pens write bad. All right, here we go. Or I can get one that's defective first and then get one that works. Okay, so again, notice the words I'm using. Works and defective, that means multiply. Or that means add defective and works. Okay, so now I multiply. So let's see, if I multiply those together, that's going to give me 27 out of 132 plus 27 out of 132 is going to equal 54 out of 132, or 0.41. Right, that's right, 25, yeah, 54 out of 132. Okay, here we go. Next page. Number 10. Where is the paper? There it is. Okay. Number 10. 4 kings and 3 aces are mixed and drawn one at a time. 3 cards are drawn. Find the probability that our 3 cards are drawn or aces if each card is replaced. Okay, so let's see, how many aces do we have? We have 3 aces, so the probability I get an ace is 3 out of my total. So 3 and 4 gives me a total of 7. And I put the card back each time. So that means my probability doesn't change. So I'm going to multiply by 3 out of 7 3 times because I want 3 cards. So 3 times 3 times 3 is 27. 7 times 7 times 7 is 343, which is approximately 0.079 if you type that in the calculator. Okay, then the card is not replaced. So the first time I draw, I still have a 3 out of 7 chance that I get an ace. But then I keep it and I don't put it back. So that means there's only 2 aces out of 6